Hi, this is Bruce with OceanPlanet Energy, and today I'm going to be showing you how to program a Wakespeed alternator regulator using our OceanPlanet Energy Tether interface. We call it the OPE Tether, and it's a user interface to program a very complicated but very capable device, the Wakespeed alternator regulators, especially the APS500 version, which has the most capabilities of any alternator regulator out there. Anyway, assuming you already have your tether connected to the regulator, which I can show in another video, but here we'll just concentrate on the programming. We are connected to this tether here is connected to a Wakespeed regulator. And so it's powered up, and so it broadcasts its own Wi-Fi. The tether broadcasts its Wi-Fi. So this computer has a plug-in connection, so I can also connect to the Wi-Fi. I can do that right now. And then I'll go to a particular address, which is 10.10.10.1. Go to that address when you're connected to the tether Wi-Fi, and you'll get this interface where you can log in to the tether. Default password is admin, which you can change. Google wants me to change it, but we're not going to. And here is the basic interface for programming the regulator. You'll notice that there's a number of tabs here, which is the different tools will guide you through what each one of these do. By the way, sometimes if you don't want to get into all this, we could do it remotely. You can activate remote access. If your tether is plugged into the internet, ours happens to be, you can go to remote access, enable remote support, and you'll get these URLs here. And if you let us know what these are, actually all we really need is this last 4 digits here, then we could access it remotely if you have a support contract worked out with us. In the meantime, let's go back to the programming interface. App settings is where you select the regulator that you want to program. If you're not plugged into one, you'll just see select regulator and you won't have anything to pick. But since we're plugged into one via USB, that is, we have the lid off of the regulator and it's plugged in to the tether with the USB cable, it'll show up as soon as you plug in. It shows up here and you can hit that and select it. So configuration mode is what you can do if you're going to program and actually send the program to the regulator, you want to have the regulator in configuration mode, which means it doesn't try to run. If you don't have it in configuration mode, it'll be trying to run, or if it's actually installed in the boat and you're changing the programming, you'll be changing the program on the fly while it's running, which you really don't want to do. So we usually start them up in configuration mode, but then we'll, when you're done programming, we'll turn that off. So this one is already started up in configuration mode. Now Reg Settings, this is app settings, which we use to connect to it. Reg Settings is the page where we adjust all of the regulator settings. There's a good number of them. We'll get into that in a moment here. Before we go to that, let's go to Tools. I want to show you this because here you can see that it checks the status. You're connected to the regulator. The regulator is now in configuration mode because we selected that. In alternator state, if it was running, you can monitor the regulator while it's running and it would tell you what it's doing here. But since it's in configuration mode, it means it's not doing anything. It's just in configuration mode. So let's say we want to create a profile. By profile, I mean the whole file of settings that tell the regulator how to run. In this case, we're going to program this particular AP500 for a set of Lithionics 24-volt lithium batteries. And if you go to Profiles, top bar here, Wakespeed produces a good number of charge profiles that for a number of popular batteries, from lithionics to Victron, a couple different types of Victron. So these may be all that you need to do is one of these, but usually use these as a basis for fine tuning for your particular application. So here we have one for lithionics, never die, CAN connected, which means it would be connected via CAN bus to the lithionics batteries. That is, the lithionics batteries will be networked together with the Wakespeed controller, which is the way that most of the high-end lithium systems work. They network together with the Wakespeed, and so that they work hand in hand to have the most organized charging, the fastest charging possible, but dynamically controlled by the battery BMS data. So anyway, so you're on this page and you see these tools as restore, program, refresh, export. Restore basically loads the profile into the Reg Settings tab. It loads into this Reg Settings tab over here. I think it should be called load or view rather than restore, but so it is. It's restore. So let's hit this lithionics one. We'll hit restore and bring it up. And this profile description is just some stock data talking about what it does. And it gives the regulator a name. Now notice it says WS500. That's sort of a generic name for WS500, and AP500s will show up as a WS500 when you first plug it in. If you go back to app settings, it calls itself a WS500, but we happen to be plugged into an AP500. They look the same in their name here, but some of the features of the AP500 will not show up if it is a WS500. When you plug in an AP500, some features show up, which I'll get to here soon. But anyways, back to Reg Settings, where we have loaded the basic lithionics profile. Now you can change the name of the regulator if you want. In fact, we'll just call this one here, we'll call this AP500 port. Oh, it looks like I've named one that before. So let's select that because this boat is going to have 2 engines and 2 alternators. They'll be on the same network, so they need to know what they are when they're on the network there. Leave the password the same. There's charge profile. There's some settings in here, but we pretty much don't use these. We use the ones that came out of the profiles page that you saw earlier. These are some basic ones here, but we tend to leave this on this custom number 2 function inline equals float. There's a function inline. It's one of the wires that you can use to activate a number of functions in the regulator, but we're going to override this. So we leave it here, but it actually doesn't really matter because we're going to override it with another setting later. I'll show you that later. Feature in mode, we'll leave it as default. Sometimes we can invert this if you want to do certain things, but we'll leave that in there. Battery capacity, we know that this one is actually, we're going to make this a custom because we know this one is actually going to be, oh, where's not letting me select it. What that is. You can put in what you want. You can also put in can battery capacity override. So what this means is that the data from the lithium battery BMS can tell the regulator what's going on. I think I'm going to select this. I will let the battery tell it what's going on by selecting can capacity override. This is a 24-volt system. I prefer to select that rather than use auto detect. So that's some basic stuff there. Okay, so we can fine tune that capacity later. Okay, advanced settings, which is really the meat and potatoes of all the functions you can do. So we'll go our way down these in this section, and then we'll work our way across the tabs. So this one here is the battery temp sensor used as a second alternative. No, it's just there. We're not going to use that. The target alternator temperature, we are using an American Power Systems HPI, which can take quite high a temperature, so we tend to raise that up to 120. They use an internal thermistor in those that's connected to the Wakespeed regulator harness. The 24-volt ones can only have a maximum field of 62%. And so we want to set, we won't be using this alt derate small, but we want to be sure that just in case it ever defaults to that, use a lower number there. So this is the percentage of the field voltage. You know, the way that most alternator regulators work is they use PWM to chop up the voltage being fed to the field on the alternator. And that's how they control the magnetism of the rotor in the alternator, which the engine is spinning around. But certain alternators, depending on the type of rotor they have, can never run at 100%. This is an example of one of those. 62 is actually full blast. You don't need to go any more than that. So I'll derate half. Let's just set that to 0.31, which is actually half. And this RPM field pullback factor is something you would use more often with the WS500 rather than the AP500, because you can adjust how it kicks in at low RPMs. But we're going to adjust this later. It's another one of those things that will sort of override that you saw up here about this charge profile selection and this RPM based selections. With the AP500, you can customize that. So, well, I'll just jump ahead here for a moment, just so you can see. There's a page over here where you can adjust all the RPM loading percentages. But we'll get to that. Okay, so we're not going to do anything to RPM field pullback factor. We're going to leave it on 0 to disable this feature. No need to cap the amps. Now, if you had a current shunt located on the alternator output, you could actually limit the alternator current itself. In some cases, you may need that. We don't need to do that here. System cap in watts. We aren't too worried about that. This is a pretty big system. On some smaller systems with very powerful charging, sometimes you have to play around with that. We're going to use a typical current shunt. Now, this system will get its current from the battery BMS, but it will also be connected to a shunt. So it has both methods of recording current. It'll default to the battery BMS data when it's available. But we happen to be using a Victron Smart Shut 500 amp 50 millivolt, which is the most common shunt there. So that's a 10,000 ratio, 500 amps divided by 50 millivolts. So we leave that there. Shunt polarity is normal. Now, if you're later on when you're running the system and you find out it's reading backwards, it happens. You can actually change the wires on the shunt, or you can go in here and switch it to reverse that. Idle RPM. We're not going to mess with that. Once again, that's tied to this field pullback factor up here. You can play around with that with idle RPM and that pullback factor when you're using the WS500 to fine tune how you want to load up. But we're going to take care of that in the RPM settings for the AP500. So warm up delay, 30 seconds. That's kind of standard where it waits before it starts ramping up the loading on the engine. Now, required sensors, you can set the system so it won't run if any of these are missing, right? If it depends on how paranoid and how careful you want to be. And this is important with lithium batteries. Sometimes you may not want the alternator to run while you're motoring along if there's something wrong with the batteries, right? If it's disconnected or something. Now, the BMS will shut it down, but you can have that in here. So in the default of Lithionics, it looks for this CAN bus data, and if that's missing, it won't run. So we'll go ahead and leave that selected for now. You can also choose on maybe with a lead battery system. I almost never do this with lithium. With the lead battery system, you could choose to ignore sensor so that it'll just keep running if something is wrong. But with lithium, we kind of want to be more careful. If something's missing, we'd rather not run. Okay, so these are some more settings down here. We'll get to those. Let's finish up here on top. Okay, so this was we called SCA. This is the alternator settings, alternator temperature. We've done that. Now, usually on each page here, before we go along too far, hit save and apply. And that's not sending it to the regulator. It's just saving it in the Reg Settings page on the tether. Because remember that we loaded that profile in from the settings, and we don't want it. We're changing them, so we don't want to have it default back to the other ones. Okay, so we're back on the page here. So let's go to the next tab over. This SCT. This is where you set your in order for the regulator to know what the engine RPM is, it gets a stator feed from the alternator. And that, of course, is the number of pulses the alternator produces alternating current. And you have to know the ratio. It has to know the number of poles, and it has to know the pulley ratio to know what's going on. So so happens that the HPI alternator is 16 poles. It's 8-pole pairs. And this particular boat has a pulley drive ratio. It's the stock one, which is sometimes you may have a custom pulley ratio, and so this could be much more aggressive. But this one, stock one, is actually it's probably about right. We can fine tune that later. But so we're going to leave that where it is. You can here again. You can do another RPM based setting if you want. We're going to do this later once again, so we don't need to do that. Okay, so that is the SCT tab. We're going to use the default pulley ratio. We think that's pretty close. And the number of poles is 16 for the HPI. Once again, save and apply. Keep in mind that what we're doing is we're building a profile here, and then we'll save this when we're all done before we load it into the regulator. This is all just building the profile. Next tab over, I just hit save and apply. It saved those. CCN, this page has to do with the CAN bus communications. When you're on a CAN bus network, devices have IDs so that they know who's talking on the network, and they have device priority. Don't need to change that. They're on the same battery bank. If this, like I mentioned earlier, this boat has 2 engines and 2 regulators, 2 alternators, but they're all on the same battery, so that's going to stay 1. And the device instance, we'll leave the port one 1, and when we do the starboard one, we'll make it 2. We just got to remember to change it so as they're talking on the network, they're not saying they're the same one. And the shunt that is going to be on the battery. The default is to leave these checked. This has to do with the data it's putting out on the network. OSC is the RVC CAN bus protocol that these devices use. We pretty much always leave that activated, and we do enable in 2K, NEMA 2000. We have a gateway where we can get that data into your N2K network if you want. Enable alt CAN. What this means is alternate CAN bus. In some battery systems have an alternative way of communicating a different type of language. We're not going to do that because we're using the lithionics, and it's using the RVC, which it gets along just fine with. The engine ID will call port. We'll give that engine ID also 1. And we just have to remember that if we set up the engine, we'll call it 1 as well. So it knows what. So this regulator knows what engine it's responding to. The default CAN rate with lithionics is 250 kilobytes. You can set a disconnected DC disconnected battery voltage here. You can set this if you want it to run if it loses the voltage sense, but we leave that 0. We don't want it to run unless it knows what the battery voltage is. Now, aggregate BMS for the lithionics, it can take multiple BMSs and add them together to create one bigger battery bank. In this case, it will be just 1 BMS. So It doesn't really matter what this is set at. But if we had, let's say, 4 BMSs on a really big system, it aggregates the data for the total current and total amp hours, etc. We'll leave that the way it is. Okay, we didn't really change much there, but let's go save and apply just in case we did. Something to remember, I suppose, is that if you don't know how alternators work, and in general, some of this stuff will be pretty much Greek, but it's this interface and the Wakespeeds allow you to adjust every single parameter you ever thought of and a whole bunch you never did with alternator regulators. That's what we're doing, of course. Okay, so this next tab here, the CNG tab, this is where we can adjust a couple of important factors. This is unique to the AP500. If you're plugged into a WS500, you would not get this tab. This allows you to program the max load on the engine. And you might wonder what J1939 max load is. Well, it's technically not load per se. It's the amount of fuel that the engine is applying to try and reach the target RPM. With the newer fancy engines, they have limitations on how much fuel can be applied in order to reduce emissions so you don't soot. And for a given target RPM, there's a CAN bus figure that comes out over the CAN bus communications that says how much fuel it's applying. So you could say, one we've used before is 60%. If 60% of the fuel is being applied in order to reach the target RPM, and if the fuel being applied is more than that percentage, then the Wakespeed regulator will scale back the loading of the alternator to keep the engine below this percentage of fuel loading. This is a unique feature to the Wakespeed and also the integral systems, another system that we sell. Very high power. When you have a very high power alternator on an engine and you want to have full power from the engine, you want to back off on the charging so you can move the boat at full speed. And so having this cap here does that. Now, that's only if you have CAN bus communications with the engine. You have to have J1939 CAN bus communication. That means it can be on the same CAN bus network that the batteries and the regulator are on. They can all be networked together. Okay, so that is a figure there that overrides pretty much everything else that we do here. But let's say we know the max RPM of the engines. In this case, we're going to say 2800. RPM field modifier. That's a way of saying, well, what's the max RPM that you might want to have? But what this does is this just becomes a way to split up. Here we hit refresh RFM labels, which is RPM field modifier labels. We hit this, and this will divvy up the RPM ranges by the max RPM that we came up with. So to give you an idea of how this would work, a common way to adjust this is you kind of typically don't want to have 100% loading at low RPM, just so you're not overloading the engine. Of course, the alternator doesn't really kick in until it's spinning pretty good anyway, so you don't need to get too worried about this low-end RPM stuff. But in order just to reduce the chances of stalling the engine, you might do a graduated curve, something like this. And once these are 110 horsepower engines, they're not high RPM engines these are going on. So once you're in this range, we're pretty much above idle. And here, let's go a little bit slower here. Let's go 60 and and 70. And then once we're going about this RPM, the engine typically has a whole lot of what they call headroom or white space available between what's required to load the prop at that RPM and what the engine could actually drive. And all the way up until full RPM, you can pretty much take full charging load. But when you get to higher RPM, you're probably trying to motor the boat pretty quick, and you would probably rather drop off this charging to not overload the engine too much. So let's just pick a basic curve here. And once you're going above 2,500, 2,800 RPM. Now keep in mind, if the engine goes faster than that, it just keeps the same setting all the way up. Let's go for 40. So we've made, basically, I've made a loading curve here. And this can be changed later. And this is what we've used arranged like this is what we used successfully in the past, and in practice works basically pretty well. Basically, you want to charge at full power across the middle of the RPM range. Now, let me back up a little bit here and say enable with feature in. This is where I was talking about how we override the setting on the feature in. The feature in is one of the wires on the harness that we saw back here. Oh, I'm sorry, it's up here. Feature in. You select a profile and function in or feature in. It's the same wire. It's just one of the wires that allows you to turn some things on, some functions on and off. But what we do on this tab is that we make it so that when that is voltage on that wire, it is in the curve mode here, the loading curve mode. If you take voltage off the wire, then it'll go back to generator mode, which means you would get full power here instead of 70%, if you so desired. Some people just leave it on all the time. Okay, so let's hit save and apply. By the way, when we do the starboard alternator, we would just, we'll save this profile and we can load it and just change a few things, right? Because everything else will be the same. We just change like the canvas ID. All right, where were we? Okay, we're done with that. Now you'll see this CDD factor. This has to do with the new Wakespeed and APS, American Power Systems, DC-DC converters, which we don't have in this system, so don't have to worry about that. Again, there's a lot of functions to program in this thing. Sometimes you may not need to use them. All right, let's get down to the battery stuff here and some of these other voltage set points. This is a 24-volt system, so you got to remember to change this to a 24-volt, which is, in this case, our target absorption voltage for lithium ionics is 28.8. We can say our exit duration, we never need to spend more than a half an hour at that. And the exit amps, now this, it says exit amps. This is tail current here. This is now advanced charging systems can tell if the battery is really charged or not. So rather than running just on time, if the current tapers down to, this is a percentage, 10% of the capacity, which in this case would be 63 amps, so we're going to lower that down to, say, 6%. Then when you're holding the target voltage of 28.8 and the current required to hold it there gets down to only 6% of the battery capacity, then it'll go to float. It won't go through this whole 30 minutes, which is desirable with lithium, because lithium batteries, if they're fully charged, you don't want to keep them at full. You don't need to keep holding them at the full voltage. They do better over time if you don't spend too much time 100% full. Well, let's hit save and apply again. By the way, if you have us create a profile for you, we can email it to you and you can import it and put all this stuff in here and not have to do it yourself. Okay, we'll get back down to where we were. We took care of that. Now this overcharge mode is a is you can set with lithium batteries to, at a certain point, you can do a lower current, higher voltage charge. But we're going to just stick with that absorption the way it was. And we're going to disable these and exit amps. We're going to 0. Now, standard transfer to float. That would, the way that usually works is that when we've reached our target here, whether in time or in current, the regulator will then back off just the target voltage is the new float voltage, which will be 27. But if you uncheck standard transfer to float, then that will it'll control the amp drop. It won't suddenly just drop off. It'll help. If your RPM on your engine panel is reported by the stator signal, sometimes with lithium batteries when they're full and there aren't any loads, when the alternator transitions from absorption to float, there's no field required to run the alternator, so there's no stator coming out of the alternator, so there's no RPM on your engine panel. So this is one way to deal with that. But on larger boats that tend to have higher loads, this usually doesn't matter. We just leave a standard transfer to float. It all depends on what kind of loads you might have. So float, we're going to change this to 27.0. We're not going to limit amps. So when it's in float mode, the delivered amps will be monitored and regulated this value. So it actually will control the current to try and hold the current to 0 on the batteries. You can set to -1 to where it just goes on voltage only, which is the way that most regulators work, just on voltage. But when it's in float, it'll try and hold it at amps. I think we usually prefer to go -1 where it just goes off the voltage, which means VBAT set point will be used to control the float mode. When VBAT set point, which means the target voltage, which would be 27. We don't mess around. Typically, we don't mess around with this exit duration, where after a certain float, it'll go back. Here you can program if the battery capacity reported by the BMS goes down to a certain amount, you can go back to absorption again. That would only happen if the loads are greater than what the alternators can put out. So that's very unlikely to happen. So actually, I think for this boat, I think we've been doing 80%. Now this, of course, we want to change. This is if you're in float and the voltage goes below a certain amount, once again, if it current overpowers the alternators, then it will go back to a target of absorption. Usually not much need for this to happen, but just in case it does, we can have that there. Revert SOC, this is the amp hours percentage. This is stated charge, which is does the same thing. It stated charge in SOC. Oh, I'm sorry, this is amp hours. Duh. I'm going to disable that. If the batteries get discharged to 80% state of charge, then we'll go back to absorption again. It shouldn't happen while your alternators are running. A very powerful charging system. Probably not a concern. Save and apply. Yes, this can take a while. All right, we're done with our float settings. This is this post-float functions, which once again, Wakespeed has so many capabilities that you don't even need to use. We almost never use that. With lithium batteries, you never use equalization. That's what CPE means. This is equalization mode. We never use that in lithium batteries, so this should all be zeros. Same with post-float, all zeros. CPE, all zeros. CPB, and this is the battery temperature and other stuff here. And now if it's a lead battery, you would have VBAT comp. This is temperature compensation. with lead batteries are very sensitive to temperature, and depending on the temperature, you would adjust the voltage. The regulator would adjust the voltage. With lithium, we do not do temperature compensation, so these stay at 0. Also, here's a minimum charge temperature. With lithium batteries, you can't charge them if they're below freezing. So here we set 2C as the minimum temperature. And the maximum charge temperature, these lithium batteries can actually charge up to 50C. Above that, though, you want to stop. And so that would be the maximum charge temperature. And also, if you can set, if the voltage is below a certain amount, you would charge slowly, but not too worried about that. And also at the bottom end, now here, this reduce low temp and reduce high temp is the temperature at which you reduce the current. When you start getting close, rather than just waiting till you get down to 2C, if it gets down to 5C, you'll reduce the current just to mellow things out. Or instead of waiting till you get to 50C, which is quite hot, you'll back off when you reach this reduced high temperature at 40C, which is like 104 degrees Fahrenheit. So we would slow down the charging in order to hopefully not get to the cutoff temperature here. So we just control things. Now, in this case, the maximum battery amps. Since this is being reported, this battery current is being reported by the BMS and or the shunt, this reporting current, the regulator knows what the current is. And on some systems, you may not want to exceed a particular amount of current. This is a 400 amp BMS. That is the BMS that has 400 amp rated contactors in it. So we might set this to, say, 380 amps. So that we don't ever, if there is other charging sources, that the total charge rate won't exceed that amount of current. We have to set this on both of the regulators on there. You might wonder when we're going to be done with this, but we are just about finished. We went through these settings here for the absorption. We went through the overcharge stuff, which we turned off. The float settings, which are important, and our float voltage, and our revert volts, and the revert state of charge. We didn't do anything on post float. We make sure equalization was disabled, and we did made sure there's no temperature compensation. We did our temperature settings and reduced current at high cold temperatures, high and cold temperatures. We got all that done. We did all our settings up here. Went through our alternator settings, our RPM, tachometer settings, the CAN bus stuff. 1 and 1 for this one. Our RPM based loading curve, that's all done. We have a profile. Okay, so what are we going to do with this? Well, first thing we're going to do is we're going to save it. We're going to go to Profiles, where we loaded up. This is where we had loaded up the basic Lithionics program to start with. But now we're going to hit Add. And you'll notice at the bottom of the page, we have a new field. Now, those settings are loaded into this, but we need to name it. We're going to call this Bella AP500 port. And we'll say this is AP500 driving 28 volt HPI or 630 amp hour LI3, which is my code for Lithionics. So we put that in there. We hit save and apply. This will save that name onto that profile. Now keep in mind, we're storing this on the tether right now. So this will be in this tether forever, unless you delete it or change it. just scroll down to all these things here. This is now on our list of programs. You can export it. You can email this file. You can save it. You can email it. Usually for clients, we'll save these and have a file just in case they lose it. Now, we've done all this work and we haven't yet sent it to the regulator that we're connected to. Remember the regulator? That's what this is all for. We're programming regulator. That one that's in configuration mode that we did in the beginning. We've been working on the tether now to build this. Well, now that we've created it and we have all the settings here in Reg Settings, all those things we went through, they're all still here. We go to Tools, you go to Program, and all that work we did basically was to create this set of numbers here. If you knew what all these numbers would mean and how to program it and could do this command line control stuff, then you wouldn't even need this interface. You just would create all these numbers and send it to the regulator via PuTTY or interface like that, which the Wakespeed designers can do. I need to use this interface here. So anyway, if we use commit, we're going to write the program to the regulator, the one that we're connected to. It's transferring settings to the regulator right now, that one that's in configuration mode, so it's not trying to run. Now, if you go to syslog, system log, this is a good way to monitor what's going on. You see how much is happening here until we send this program. Now here you can see that it's sending things. It's sending all that data that you saw a minute ago. And you see A-OK, that's good. It means it's working. We can go back to Tools. It'll give us this task of what's going on. And it's restarting the regulator. Success. We've programmed an AP500 regulator. So now when you go to actually run it, some boats leave a tether installed in the system on the network. And if you do that, then you don't want it to stay in configuration mode, right? Because it won't run then. So you'd want to say, don't start up in configuration mode. In this case, I'm going to go program another one here pretty soon. When you repower the regulator, it won't be in configuration mode. So if you don't have a tether connected to it, it doesn't matter. But if you have a tether in your system that's networked together with your regulator or regulators, then you want this unchecked when you're not programming. So now if I hit save and apply with that unchecked, and you go to Tools, you'll see that we have turned off configuration mode. Now the alternator state is still in configuration mode until you reboot which you can do with either the power or you can hit reboot regulator. In Tools, that was on Tools page, by the way. In another video, we can go through what all these, some of these other controls and tools can do, but that certainly is enough for today. See, now the alternator thinks it is running. Alternator in delay mode while engine warms up. It doesn't have power on its wiring to run the field, so it can't actually run anything right now. But if it was installed in a boat and we were programming it, it would now be able to run once it's powered up. In another video, we'll talk a little bit more about monitoring, but this AST tab over here, we saw syslogs. You can do logging. We can do logging. This AST tab is where we spend most of the time on the tether, actually, aside from all this programming. Once you have a system up and running, you spend most of your time on this AST tab to monitor. You can do this on your phone. You know, once you're connected to the Wi-Fi of the tether, you can monitor all this data. The hours that the regulator's been running, what the battery voltage is. We're not hooked to the battery, so it doesn't have any voltage. The current, what its target, it's trying to do, what it thinks the engine RPM is, temperature, all this data it's on a test bench right now, just connected by USB to the tether, so it doesn't have any of this data. But once it was wired up and connected to the battery, you'd have all this information here. And with remote access, you could send us the URL, and we could look at this, and we could help troubleshoot any problems that might come up. If it's not charging, we could say, oh, you don't have any RPM. So it's not time to run yet. So we need to find out why it's not doesn't have any RPM. That's an example. Anyway, that is a very long-winded explanation of how to program an AP500 regulator with OPE Tether.